Hey everyone, Mr. Fugay here, and this video is going to be talking about polynomial addition and subtraction. So the addition part is going to go fairly quick, as it is very similar to the concept of combining like terms. So just a quick vocab recap before we start moving into things. A term, so we were talking about polynomials. Polynomials is a collection of terms. So the first term right there, 2x squared, okay, is a term. So terms are expressions with variables and numbers that are connected through either addition or subtraction. So 2x squared is a term. The number in the front, the 2 itself, we call that in math the coefficient. So throughout the video, you're going to hear me referring to that term coefficient. The other number that I'm going to refer to is the exponent up here, and this is called our degree, or I might just call it an exponent. But those are two terms that we're going to be using here. And again, overall, the entire thing, this entire thing is called a term, which is the whole point of this lesson. We're taking terms that are grouped together, and we are going to add and subtract them together. So, as the notes say here at the top of the page, in order to add polynomials, we're going to add the coefficient of like terms. So what makes something a like term? If it has the same degree. So if it has the same degree, by definition, it's going to be a like term. So 2x squared, for example, will be like terms with x squared. So I'm going to highlight them both in yellow. We're then going to look at our next term, which is x, and that's raised to the first power. And that is going to be a like term with this x here. And last but not least, we have our numbered term with no variables. We call that our constant term. And that will be a like term with other constant terms. So in addition, it really boils down to this. Once we now have identified our like terms, we're going to take those coefficients in front. There's not one written, it's assumed to be a 1, and we are going to add them together. So 2x squared plus 1x squared would give me 3x squared. In my next term, we would have x plus x, since there's no numbers or coefficients in front, they're both 1s. 1 plus 1 would give me 2x. And last but not least, we're going to take our constant terms, negative 5 plus 6, and that's going to give me a positive 1 here. So just to confirm on our final answer, 3x squared is the combining like terms of my degree 2. 2x is going to be my combined like terms of my degree 1. And last but not least, the 1 is going to be the combining like terms of my constants. Let's take a look at another example or two where we're going to take this principle and use it a few different ways. So in this problem, we have something with a degree of 3, 5x cubed. So we see that in the second set of terms, we don't see anything there, but in the third set, we do see the negative x cubed. We're then going to go ahead and move on and do this with the x squareds. So those are all my x squared terms. Mind you, we do need to be careful and mindful that if there was a negative sign in front, we do need to include that. So like, for example, I'm going to highlight that here for my x term, my negative 4x, because the coefficient is also going to include the sign that is in front of the number. Now, for the last one, our constant term here, we'll use purple for this. We have positive 7, negative 8. So when we do our final answer here, we're going to take all of our yellow terms, we're going to add them together. Then we're going to take our blue terms, then our green terms, and lastly the magenta or purple terms here. So let's go ahead and go through that one more time. So we have positive 5, negative 1. That's going to give me 4x cubed. Then I'm going to have my 2, my 3, so that's 5. And then 5 plus 4, that's going to give me 9. So 9x squared. We'll put a plus in front since the 9 is a positive number. We have a negative 1. We have a negative 4. So that's going to give me a negative 5x. So that's why I'm putting the minus there. And last but not least, we have positive 7. Oh, I missed one. Over here, we have another positive 7. So watch out for that. If not, everything's not highlighted, that'll be a big hint. Positive 7 is 14. And then 14 minus 8 should give me a positive 6. So this is going to be my combined like terms for my second example. So now it's your turn. You're going to try out a couple of these examples yourself. So please go ahead and pause the video. Here are 3 examples on the next slide. I would like you to pause, try it out, and after a few seconds, I will have all work and answers on the screen. Right, welcome back. And at this point, hopefully you've gone ahead and tried these out. Here's our first example. And just something of note, when I take my blue terms and add them together, I got 0x. Now you can technically write that, but as we know, 0 times anything is 0. So when I wrote my final answer here on the right, I didn't include that term when I wrote my final answer. That's going to happen in number 2 as well. My constant terms, positive 2 and negative 2, end up canceling each other out. And we once again are just not going to include that in my final answer. One thing also that I didn't talk about when we were going over this is we do typically want to write our answers in standard form. That meaning we're going to write our highest degree term first, and then we're going to be descending down to our constant term last. So that's why we start with our cube term, our square term, our x to the first, and lastly our constant term. And once again, for the third example here, you'll see that the x to the first term also canceled out, -1, +3, and a -2. But overall, there are the 3 answers, and at this point, if you feel comfortable with this, let's move on, and we're going to add one final wrinkle to this as we talk about subtraction. So here's an example. So it says, when subtracting polynomials, you must remember to distribute the negative sign. Distribute the negative sign to each term of the polynomial. Now, let me backtrack to maybe when we learned about how to add and subtract negative numbers. You may have remembered when you first learned this, if you take a number like a problem like 3 minus 4, that a lot of teachers said to you, well, this is the same thing. 3 minus 4 is the same thing as 3 plus a -4. And there's many different reasons, and I'm not going to go into the why this is the case, but I know a lot of teachers use this idea of keep, change, and then flip. And that's a way for us to take a subtraction problem and turn it into an addition problem. So this is what we learned years ago in middle school when you start to talk about adding and subtracting signed numbers. We're going to use a very similar concept for polynomial subtraction as well. So what we're going to do is the term distribute is kind of what's happening here. You're changing the middle sign to be an addition problem, and then you're flipping or doing the opposite, multiplying by -1, to each term in the second polynomial. So for example, here we have a problem 3x squared minus 5x plus 3, but then we have a minus sign, so we're going to be subtracting 2x squared minus x minus 4. So what we're going to do here is we're going to use that same idea of where we're going to keep, and then we're going to change this to be an addition problem. And then in this entire second term, second polynomial, I should say, we are going to flip all the signs, meaning the 2x squared is now going to become a -2x squared. The negative x becomes a positive x, and the -4 becomes a positive 4. So by doing that, what we now have done is we've essentially turned this into an addition problem, which now allows us to do the exact same thing we just did in the previous examples. We're going to highlight our like terms. So let's go ahead and highlight them first like we did in the first part of the video. And now all we're going to do is combine like terms. So we have +3, -2, that's 1x squared, better known as just x squared. We have -5 plus 1, so that's going to give me -4x. And last but not least, we have 3 and we have 4, both of them are positive numbers. So you would add them together, we get an answer here, and again, I'll take that 1 out of there, we really don't need that. So it's x squared minus 4x plus 7. So the only other wrinkle we've got to think about here is when we are presented with subtraction of polynomial terms, we're going to use that same concept from middle school where we're going to keep the first term the same, change our problem to an addition problem, and then we're going to flip every term in the second polynomial to then make it an addition problem. So let's see that in action again. So first thing I'm going to do is we're going to use that idea of keep, change, flip. So we're going to keep this part the same. We're going to change this to be an addition problem, and then every term in the second expression we're now going to flip. So the -13 is now positive, the -3 is now positive, the 2x is now going to be a negative, and the -17 becomes a positive. So once you've taken care of that responsibility, let's go ahead and now we're going to repeat the process we've been doing before. So this is going to be pretty standard now if you get the hang of how this is working. So highlighting all of our like terms. And that's just the highlighting process. It just helps us so we don't miss anything. As you saw earlier on, I almost made a mistake on a previous problem. So 8, 9, 10, that's 21x to the fourth. That's going to be 0x squared. We'll not write that in our final answer. This is negative 11 and negative 2, so that's negative 13x. And lastly, we have 17, 16, 15, that is 14. So if I want to clean up this final answer, it would be 21x to the fourth minus 13x plus 14. One more example we'll go through together, and then I'll have you do a couple to try as we wrap up this lesson. So here's another one. What I want you to do right now is I'm going to slowly do this, but please go ahead and try to do the keep, change, flip so that we can convert this into an addition problem. Okay, so we're going to keep the first term. We're going to change the middle term to a plus, and then we're going to flip everything in the second polynomial to the opposite sign. So negative, negative, positive. Negative, negative, positive. So it's just the opposite sign that it was when we started. Okay, let's go ahead and identify our like terms. X cubed does not match with anything, so move on. X squared will match with the negative 6x squared. 5x matches with this, and last but not least, our constant terms will match here. Okay, so the negative 4x cubed, nothing happens with that one. When we look at my blue terms, I have negative 8, negative 6, that is going to be negative 14x squared. We have a positive 5, we have a negative 2, that's going to be plus 3x, and we have 9 and 4, that's going to give me 13. So if you just take the time and do that keep, change, flip, take that extra 15 to 20 seconds to do that, you will keep these problems to be as straightforward as we're seeing them through this video. So for one final time, we're going to go ahead and have you pause, and I'm going to have you try these 3 examples. Don't forget to keep, change, flip first to change it into an addition problem, and then go ahead and proceed with the polynomial addition strategies. Pause now, and I'll have answers in a moment. Back, here are my solutions. So remember, in red is where I'm doing my keep, change, flip when you look at the red pen. I highlighted my like terms. Remember, if there is no number in front of the x, it's going to be a 1. That's why we have 1x squared, which then I just wrote as x squared at the end. And then just keeping that in mind as we look even at our second example here, same situation, okay? This 1x, which by the way did not have any like terms. There was nothing else raised to the first power. So I simply just rewrote that in our standard position when writing the polynomial. So keep, change, flip, highlight your like terms, combine your like terms by adding the coefficients together. In the last example you'll see here, after I did my keep, change, flip, my 2x cubed terms are going to actually cancel out, giving me 0x cubed. As I mentioned before, we don't write that in our final answer because 0 times anything is going to be 0. But those are the steps that we're going to take, and that's what I would like you now to take some time and practice as well. If you're looking for additional examples, feel free on the Delta Math assignment that there are help videos that will walk through additional problems as well, in addition to what I have here. But feel free to go back and look at any of these examples at any point, just to give you reminders of some of the key strategies to adding and subtracting polynomials. I hope this was helpful, and thank you for watching.